Good morning, ladies and gentlemen. How are we doing today? Good. Welcome to the second trimester of chemistry, ladies and gentlemen, or as I call it, the harder part. Excellent. All right. Ariana. Jasmine. Take out your computers, ladies and gentlemen. Get logged in. You should be part of the new Google Classroom class. Shenza. I couldn't find you. Madeline? Alex, are you sure? Check your schedule. You're not on my roster.
No. Let me check. What the custom? I mean, it should change to whatever custom you have.
Or you have personalized. I'm still money, bro. I'm not gonna go home. I'm gonna say like good on my good. Spend the money.
Oh, the classes got switched.
So where are you supposed to be?
I'm supposed to be at Mr. Fisk. Originally, I had him third out.
No, things do get changed. I will write you a pass. I feel bad for Morgan. I really do. That was it. That was her one time of being excited in my class ever. And it just got trashed, taken away from her. Just.
Just not on the I don't blame you.
Okay, it's all set. You can go.
Are you gonna help me, man?
Just remember to sign in when you get to Mr. Fisk. All right.
Shit's drunk. Oh, yeah. Someone else is-
All right, ladies and gentlemen. So tell me, what did we do? And don't say nothing. If you're going to say nothing, just don't say anything at all. Okay? What did we do last trimester that you enjoyed, that you liked, that you want to see us do more of this trimester?
No final.
What?
No final test.
No final test. That's not an option this trimester. Okay? That's not an option this trimester. I already got the test picked out for you. Just for you.
When's our first test?
What?
When's our first quiz?
Your first quiz is this week, Friday. So, again, this is not what I was hoping for as far as, you know, what things did we do in the first semester or first trimester that you kind of enjoyed that you would like to do more of? What?
Labs.
Labs.
Like
Okay.
working at the back station tables.
That is going to be a constant no matter what. Okay. Although I really, I don't know if I like the feel of this with you two this close to me. I really am not certain yet. Okay. Okay. So more labs, more work at the tables. Okay. Anything else? That's it? Okay. Well, wow. I can make that easy, kind of, maybe, somewhat. All right. Here's what I will tell you, ladies and gentlemen. The second trimester is harder than the first. Absolutely no question about that. The second trimester, ladies and gentlemen, there will be a lot more math. Now, the calculators are out back there, ladies and gentlemen. Okay? Again, if one goes missing, then I'm going to require you to give me your phone or your ID to get one. As long as they stay there, that's fine. Okay? You will need a calculator most days in here from here until Unit 8. Okay? Just so you know. You have your own, that's fine. You are welcome to use it. All right? But if you don't, you need to grab one when you come in most days. Okay? Today we're going to be talking about the mole. We have already discussed the mole. We have already introduced it to you. It is one of our 7 base units, ladies and gentlemen. The mole describes the amount of substance. Okay? The mole is a specific number. All right? So we will get to that in a minute. Okay. Google Classroom site. You were all invited. Is there anyone who cannot get into the Google Classroom site for second period chemistry units 5 through 8? We are all good. Okay. In here, ladies and gentlemen, again, daily agenda. And I'm going to try doing this. We'll see how this goes, ladies and gentlemen. So, again, the daily agenda, if you miss class, if you are homesick, you want to look at what we were doing that day, I will also try to post the video of what we did in class that day. So right now I've got the video running. I'm recording what we're doing. It's a recording of this screen. So obviously you won't see if we're doing something in the back or things. But whatever I'm broadcasting on this screen, you will see. And whatever I am saying and you guys say in class, you will hear on the video. And I will put that into there. Okay? So I will try to do this for you so that if you are ever absent, if you're sick, if something happens and you're going to be gone, here's a chance for you to get the information and make it up. The second trimester of chemistry is very similar to the first in that there are 4 units just like there were in the first try. Here's what I will tell you. I will be a little bit more even with the units. What that means is basically if you take 12 weeks and divide it by 4, that means every 3 weeks we're going to be having a test. Okay? Now, I haven't taught chemistry in a while, ladies and gentlemen, and that's why in the first trimester, the first unit took a long time. Okay? After that, we kind of shortchanged Unit 4 a little bit. I will make adjustments in the future to that, but I can tell you this. My plan is about every 3 weeks. So we'll have a week, take a quiz, have a week, take a quiz, have a week, take a test. Okay? That is the plan. Okay? Now, there are some, next week, Friday is an early release day. Okay? But basically, ladies and gentlemen, the nice part about this time of the year is there are 12 full weeks of class for this, unlike the first trimester where there was a little bit less than that. So that's out there for you, ladies and gentlemen. Again, still have your periodic tables, still have your solubility sheets. You're going to be using those all trimester long, okay? If you want new ones, you are welcome to come up and grab them. If you want extra ones, you are welcome to come up and grab them. But again, on a quiz, on a test, you can only use one of each of those, okay? One of each of those. Now, the things that we learned in the first try, we are continuing with them. The biggest thing is the naming. The naming that we did in Unit 3. The writing single and double replacement reactions that we did in Unit 4. We are continuing with that in this trimester. Okay? So if you have notes on there that are valuable for that, you can use that periodic table. I don't care. But if you want new ones, they're here and they are available for you. Okay? In Google Classroom, ladies and gentlemen, also, here is your EISN. Here is the presented EISN. Here are the worksheet answer keys for the entire unit, ladies and gentlemen. Those are scheduled to post tomorrow at 6 a.m., as well as the mole versus the mount lab, because we're doing a lot more math in this unit. Okay? Because we're doing that, your worksheets will be on paper. Okay? Matter of fact, ladies and gentlemen, no, that ain't it. It's in the other one. I have a packet of worksheets already stapled up and ready to go for you. The worksheets for the entire unit are together, ladies and gentlemen. Here it is. Okay? So I'll give you one of these tomorrow, but the answer keys are right here for you when you are doing it. Okay? The idea is the answer keys are there so that if you do a couple problems, you check it, you see if you are doing correct, you keep going on. If not, talk to me. Now, here's the other thing that I will tell you too with this unit, ladies and gentlemen, and from here on out. From here on out, ladies and gentlemen, we are going to be using this a lot, starting today with calculating molar masses and formula masses. When you calculate a molar mass or a formula mass, Phoebe may calculate it and I may calculate it, and we may be slightly different. What I mean by that is I have a lot of these masses memorized from an old periodic table. So on this one, it has carbon as 12.01. In my mind, carbon will always be 12.011 because that was the old periodic table I used to work with. Oxygen on here is 16.0. On mine, it was 15.9994. So if I use 15.9994 and Phoebe uses 16.0, we're going to have a slight difference in our final masses. That is okay in this unit. Slight differences are okay. By a slight difference, that doesn't mean I come up with 72.6 and she comes up with 38.1. That is not a slight difference. Okay? So please understand that. Now, that doesn't mean that we can't do sig figs. That doesn't mean that I don't expect you to get the same basic answer as me. But if your number varies in the tenths or hundredths place a little bit compared to mine, I will not be downgrading you for that. If your number varies by 5 grams, yes, I will be downgrading you for that. Okay? So please keep that in mind, ladies and gentlemen. So if you go up to somebody else and you go, okay, what'd you get for number 7? And they go give you a number, and you're like, oh man, I didn't get that. Did you get like really close to that? Yeah, but I didn't get that number. That's going to be why. Just so you know. Just so you know. Questions? Okay, same thing as the first try. What I mean by that is no food in here. You want to bring drinks, things like that, absolutely fine. Okay? I only have so many charging blocks. I have no idea how many other classes are going to be using them. Okay? When I'm out, I'm out. If I got them, I got them. Okay? Phones still need to be put away. Headphones still need to be put away. Okay? I'm not giving out warnings. Your warning is you now have a choice. You put it in the box. You take it down to the office. Your choice. Okay? Your choice. All right? If it falls out and hits the floor, sorry about that. Put it in there. Okay? So keep that in mind, ladies and gentlemen. Questions? All right. Open up your EISN, ladies and gentlemen. It is the one right here in your notes or in your Google Classroom, and it should look like this, ladies and gentlemen. Let's talk about the mole. Okay? Let's talk about the mole. Now, in this unit, ladies and gentlemen, there are a few things that we will be doing. Oops, didn't want that. A few things we will be doing with the mole, ladies and gentlemen. Okay? So we're going to talk about the mole, just review what it is and things. We're going to talk about calculating something called molar or formula mass. Now, remember, I told you before, if you cannot write the formula for sodium carbonate, you are in trouble. Why? You can't write the formula for sodium carbonate. You can't find its molar mass because its molar mass is based off of its formula. So all that naming stuff, boom, right back at you. Then we're going to take and we're going to convert the mole. We're going to convert it into a few different units. Mole is the base unit for chemistry. Everything goes through the mole. Everything does. And if I give you a mass of something, you should be able to convert it into the mole. If I give you an amount of a gas, so many liters of gas, you should be able to convert that into moles. If I tell you there are this many atoms, this many particles, this many pieces, you should be able to convert that into moles. Moles is the central unit that we are going to use in the rest of chemistry, ladies and gentlemen. All the way through Unit 7. Okay? We're also going to be able to find what we call an empirical formula. The formula of a compound. We are going to be able to find the percent composition. In sodium chloride, how much sodium is there and how much chloride is there? Then we're going to talk about ionic compounds in water. So those solutions that we worked with in the final exam, what happens to that ionic compound when we actually put it into water that makes it aqueous? What does it do? And then why do some things become a precipitate? Okay? And then we are going to get to what are called ionic equations, where we will show you why, if there is no reaction, nothing really happened. Nothing really happened. And that's why we have to find reactions. Because if reactions don't happen, we didn't get anything different than what we started with. So this is the layout of what we're going to be doing in this trimester. Questions, ladies and gentlemen? Wonderful, wonderful, wonderful. So let's start with the mole. Okay? All right. So on slide 3, ladies and gentlemen, the mole. The mole is an amount of substance. That is what it is. Okay? Now, in society today, when you go to the store and you buy things, you either buy them by the what or the what normally. What are the two ways that we buy things? So, for example, if you buy bananas, okay? If you buy apples, if you buy oranges, okay? You are buying those by the what? By the pound, by mass, okay? Normally people, they'll pick them out for apples. Do you go, okay, I want 3 pounds of apples? Normally you pick it up by the quantity, right? You go, well, I need 5 apples for the week. Or I need 3 apples, or I need 2 apples. Whatever it is, right? You buy a certain quantity of them. Now that does go into how many pounds it is, and then that's how they charge you, right? But normally you buy things like that by picking them up. Okay? If you go to a place like Fleet Farm and you are looking at things, sometimes they will sell them by the amount, by how many there are there. Golf balls, pencils, notebooks. We buy by the amount, right? Now, golf balls, it's a what? How do golf balls come? Normally. Dozen. Okay, normally they're by the dozen. Pencils, it's a 10-pack of pencils. Does that mean you can't buy one? You can, but normally in the store, they're in a package. Here's a 10-pack, here's a 20-pack, here's a 30-pack, where you're buying them by that amount, correct? And then what is the other way we buy things? Nobody counts out grains of rice. Nobody counts out pieces of sugar. We buy them by the weight. We buy them by the weight. Okay? But if you go into Fleet Farm and you buy a pound of nails, do they know how many is in that box? So you think manufacturers are just like, you know what, I'm just putting a pound in there, I have no idea how many are in there, so when I sell them, I have no idea how much each nail costs?
Well, the manufacturers probably, but not like your average Fleet Farm worker.
Really?
They probably don't know how many are in that.
Well, then I don't want to talk to that person at Fleet Farm. But on the package, when you buy things like nails and it's a 3-pound box or a 1-pound box, whatever, it tells you about how many nails are in there.
Can't say they're about nails.
No! You should try it.
Okay.
It's a cool thing. Okay? It's a cool thing. Okay?
Yes.
Again, though, when we buy rice, They don't like, here's 20 kernels of rice, enjoy. Right? You buy it by the pound. You buy it by how much? Does that mean they have no idea how much is in there? No, they probably do. Okay? Tomorrow's lab hopefully will explain this a little better than I am doing right now, ladies and gentlemen. So mole is the amount of substance, and basically it is one of the 7 base units, ladies and gentlemen. Mole also relates to something called Avogadro's number. Avogadro's number is how many pieces there are in a mole. How many pieces are there in a mole, ladies and gentlemen? What's the number?
The one that's on the slide.
That would be a good place to start.
6.02 times 10 to the power 23.
6.02 times 10 to the 23rd particles. 6.02 times 10 to the 23rd particles, ladies and gentlemen. That is what is in a mole. Okay? That is what is in a mole, ladies and gentlemen. Okay? And there is something called Avogadro's law. Avogadro's law says equal volumes of a gas under the same set of conditions, meaning pressure and temperature. So name me 2 gases that are under the same set of conditions in this room.
Oxygen.
And nitrogen. Okay? Why? Because they're both in the air around us. They both have to be at the same temperature, ladies and gentlemen. Okay? And together they create the pressure in this room. If you have equal pressure and equal temperature, and you have the same volume of each, by the way, can we agree that the gases are taking up the same amount of space in this room?
Yeah.
That means they have equal volumes. You have the same number of pieces. Okay? So what that means, ladies and gentlemen, is that is quite different. If you have 12 bowling balls and 12 golf balls, which takes up more space? The bowling balls. Which one would weigh more? Why? And so when we have the same amount of something, 12 of each, are we expecting them to take up the same amount of space? No. Are we expecting them to have the same volume? No. Would we expect them to have the same mass if we have the same amount of each? No. Now, which one is heavier, ladies and gentlemen, a pound of bricks or a pound of feathers? They are the exact same. The exact same what? Weight.
Nice.
Same weight. We relate that they would have the same mass because we could convert weight into mass. What would not be the same about the bricks and the feathers? Would not have the same amount of them. You would not have the same amount of them. What else would not be the same?
The space it takes up.
The space that each one takes up. Okay? The space that they take up. Okay? So again, you have to understand what we're talking about. Are we talking about having the same number of each, or are we talking about having the same mass of each? If we have the same number of each, I can tell you how many there are. If we have the same mass of each, I can't tell you how many there are necessarily, because it's not going to be the same for both. Okay? Not going to be the same for both. Okay? The mole is a central unit, ladies and gentlemen. So here it is in the middle. And we can get to it from 3 areas. We can get to it from mass, we can get to it from volume, or we can get to it from particles. Now, getting to and from the mole from particles, we are always using the same number, 6.02 times 10 to the 23rd. Your calculator is going to get a workout with that scientific notation key. So I tell you how many pieces we got, you should be able to tell me how many moles. The number is always the same for volume of a gas in this unit. Because in this unit, ladies and gentlemen, the only way I will give you a gas is at something called STP, standard temperature and pressure. And when I give you a gas at STP, it means that 1 mole will take up 22.4 liters. Now, the one of these that is different, ladies and gentlemen, is mass. Because again, a bowling ball and a golf ball do not have the same mass. If I have a dozen of them, a lot more mass with bowling balls than with golf balls, correct? So would you expect an atom of copper to have the same mass as an atom of carbon? Don't be sorry, answer the question. Would you expect an atom of copper to have the same mass as an atom of carbon? No, not even close. An atom of carbon, 12.01. An atom of copper, 63.55 grams. Again, maybe a little different depending on the periodic table that you're looking at. But in my hand here, ladies and gentlemen, I am holding 1 mole of copper. I am holding 63.55 grams. And 1 mole of copper means that in here, right here in my hand, I have 6.02 times 10 to the 23rd atoms of copper. Where did I get the 63.55 grams from? Did I randomly pick it?
No, it's the number.
It's the number.
Below the symbol.
Right. Good terms. Yes.
Yeah,
We call that average atomic mass. So in my hand here, I am holding 1 mole of copper because according to the periodic table, copper's mass is 63.546, 63.55, 63 point something.
Do you have matches?
Do I have matches? Yes, I do.
Miss Volkowski is in need.
Of a lot or just a few?
Just a few.
Okay, well, the way she goes, I'm going to give her a bunch anyway because she's probably going to need them at some point.
This chemistry class?
You can see they're all enthralled and thrilled right now. We're talking about moles.
They look so smart. That's why I thought it was chemistry.
Looks can be deceiving. Okay, so ladies and gentlemen, that number on the periodic table, 63.55. Now that's not grams on the periodic table, right? What unit is that? Yeah, all right. You guys remember this stuff from before. That's awesome. 63.55? No, not grams. This is grams. On the periodic table, that's in AMU. Atomic mass unit. Why? Because it's way too small to measure the mass of 1 atom of copper in grams. Okay? Matter of fact, until we get a mole of it together, we really don't have much of a chance of even seeing most of the time the copper. This, ladies and gentlemen, is 1 mole of zinc. 65.37. Again, maybe slightly different on the periodic table on yours. What's it on yours, Shenza? Come on.
3.8.
What?
3.8.
3.8?
Yeah.
3.8? We're off by 1/100 of a gram. Oh my God! Let's throw everything away. Forget about it. Well, let's not do this. Let's go talk about, I don't know. What do you want to talk about? All right, never mind. You don't have anything on your head, so we'll go back to this. What is the same about these two things?
They're squares.
No, that's not a square. I don't know if your math teacher's ever taught you this, but a square has 4 equal sides and 90-degree angles in the corner. What is the same about these?
Yeah, and same shape.
There's writing on it.
There's writing on it. Oh my God, yes, let's go to the audience. There's writing on both. Okay, good.
That is writing on it.
They're 2D.
They're 2D. No, these are 3D. These are 3D. They're flat. Wow, good. You know what's the same about these?
You're holding them.
There's the same amount of pieces in both of them.
Oh, I bet.
There is 6.02 times 10 to the 23rd atoms of zinc here, and 6.02 times 10 to the 23rd atoms of copper here. Okay? There's exactly the same amount of pieces. Do they take up the same amount of space?
No.
Do they have the same mass? No. But I do have the same amount of pieces, which is very important because in a chemical reaction, if I want one of these to replace one of these, I got to have the same number of pieces there. And I can have it if I have the molar masses of each. Here's 1 mole of lead. 207.2 grams. 6.02 times 10 to the 23rd pieces. Why is this so much heavier than these?
AMU.
Okay.
One part, one AMUs. I mean,
1 AMU is heavier than a different AMU. No.
one leg is heavier than the
1 what of lead? Okay, yes, good.
particle.
1 particle of lead
Is heavier.
is much heavier than a particle of copper or a particle of zinc. Well, what is the same about all 3 of these?
Same amount.
Same amount. Same number of pieces, ladies and gentlemen. And even if we do something like, oh, I don't know, say water, in here is 1 mole of water. Exact same number of pieces as was there. Here's a mole of sugar. Dextrose. Different kind of sugar, not the same stuff you have on your table at home. That is in here. What do we know about dextrose compared to sucrose?
Not much.
What?
Said it's whiter.
It's whiter? Whiter? We're comparing whiteness? Okay. Okay. What else do we know about this one compared to this one?
There's a lot more.
There's more.
No, there's the same amount in both of these.
There's more of it.
No, there isn't. That's the point. There's not more of it in here.
Different
There is the same number of particles in here as there is in here.
Dextrose
Different
is
space.
heavier.
What?
They take different
They
space.
take up a different amount of space. They have a different amount of mass. The particle here is smaller than the particle here. Okay? So again,
That's why.
the same amount here though. 6.02 times 10 to the 23rd. If I took 1 molecule of sucrose, 1 molecule of dextrose, 1 molecule of water, 1 atom of lead, 1 atom of copper, and 1 atom of zinc, and laid them all out, guess what? They'd all have a partner. Because there's the same amount in each one of these, ladies and gentlemen. The exact same amount. Okay? The exact, not the same mass, not the same amount of space, but there's the same amount of each here, ladies and gentlemen. The same amount of each is here. All right. So, by the way, particles. Particles could mean molecules, it could mean atoms, or it could mean formula units. Now, this is a technicality, if you will. A molecule is only a covalent compound. That means that it has 2 or more covalent compound. Only has,
Non-metals.
thank you, only has nonmetals. Most of the compounds we made were what? Ionic. So technically, for ionic compounds, we have to talk about a formula unit. We cannot talk about a molecule. Okay? They are not the same technically. Okay, good, excellent, wonderful. Standard temperature and pressure. Standard temperature means 0.00 degrees Celsius. Standard pressure means 760 millimeters of mercury. Okay? Right now, room pressure is probably about 740 something, I think, right now. So we're close to standard pressure. But Green Bay is also a little bit higher than sea level. We'll get into that in the next unit. Okay? This is the only number that varies. Why? Because it depends on what is in the sample. When we go from volume to mole, we will always use 22.4. When we go from moles to particles, we will always use 6.02 times 10 to the 23rd. But when we go from mole to mass or mass to mole, we need to know what we're talking about. We need the formula of it so that we can find it out. And we can find the formula mass of water, of salt, or of carbon dioxide. How? Because we got a periodic table and we got a knowledge of how we can write a formula. Right, Angel? Good. Excellent. Wonderful. So finding molar or formula mass, ladies and gentlemen. Either way, you can call it either one. Okay? Molar masses, ladies and gentlemen, is the mass of 1 mole of any substance. It is calculated based on the formula and the periodic table. So take out your periodic tables if you haven't already. If you threw it away at the end of last try, please come up and grab one. By the way, this was left on the counters during the lab days last week. If it is yours, please feel free to come up and grab it because I'm not that into plant life.
I don't know your class.
All right. So 1 mole is equal to 6.02 times 10 to the 23rd particles. Now the one thing that can vary is what that particle is. Okay? What that particle is. If this is copper, what are the particles that make up copper? If this is copper, what are the particles that make up copper?
29.
What?
29.
29. I'm not looking for a number here. What? Copper what? What are the particles? Be more specific. What are the particles that make this up? Metal. I don't know if we're getting better or worse, ladies and gentlemen. What? No copper oxide. This is just copper. Just Cu. The stuff that's up there.
Carbonate.
No! All that's here is copper. This is a element. What is the smallest particle?
Atom.
An atom. Thank you very much. The smallest particle of an atom, ladies and gentlemen, of an element is the atom. This is made up of atoms. That can be your particle. This is water. What is the smallest particle of water? No.
Liquid.
No. What is water? It is a compound. 2 hydrogens and 1 oxygen. Good. Okay. So what is the smallest particle of a compound?
2 oxygen.
That's 3 particles. What is the smallest particle of water? What do we call it? Not an atom, not a compound, a molecule. So the smallest particle here is a molecule of water. Specifically 6.02 times 10 to the 23rd of them. But this molecule is made up of what? 2 hydrogens and 1 oxygen. 2 atoms of hydrogen, 1 atom of oxygen make up the 1 molecule of water that is in here. But that 1 molecule is the smallest part of this water. Okay? This is 1 mole of salt. What is the formula for table salt? Let's start there. Common table salt in your home. Oh, no. NaCl, sodium chloride. Okay? What kind of compound is it? Ionic or covalent? Ionic. Therefore, ladies and gentlemen, we cannot call this a molecule of salt because it is made up of ions. This is a covalent compound. The smallest part is a molecule of water. This, the smallest part, is what we call a formula unit of NaCl. Okay? 1 Na, 1 Cl combine together to make salt. 2 hydrogens, 1 oxygen combine together to make a molecule of water. Can't call this a molecule though, sorry. Okay? Good. Oh, now we're cruising. Now we're cooking. Now what's next? The mole converts AMUs, something way too small for us to measure, ladies and gentlemen, into grams, something that we can measure on a balance in the back of the room. I cannot hold 1 atom of copper in my hand. I wouldn't even know if I had one. I couldn't see it. But I can hold 1 mole of copper in my hand because that's 63.55 grams. 1 atom of copper is 63.55 AMUs. Way too small. Can't do it, ladies and gentlemen. 1 mole of a substance is equal to the formula mass of the substance in grams. 1 mole of a substance is equal to the formula mass of a substance in grams. Where can I find the formula mass, ladies and gentlemen? On the other side.
Slide.
Which slide?
One before this? No? Am I wrong?
Where do I find the formula mass for copper?
Oh! Okay, never mind.
First of all, someone tell me what the formula for copper is. What is it? Cu. Thank you. Cu. Where can I find its formula mass?
Periodic table.
Periodic table. What is its formula mass? 63.55. Find me the formula mass of zinc.
65.38.
Find me the formula mass of lead.
207.20.
Good. Find me the formula mass of water.
Give me a second.
Can't do it on the periodic table. Why? Because it's a compound. So we have to calculate it. We have to calculate it, ladies and gentlemen. 1 atom of zinc, though, has a mass of 65.39. 1 mole of zinc has a mass of 65.39 grams. All we're doing is taking and upping our scale from 1 atom to 1 mole. The AMUs become grams, ladies and gentlemen. And again, we're not going to argue if you say it's 65.38. I'm not going to argue with you even though you're wrong. Okay? We're not going to do that. Okay? Move on. 1 atom of copper has a mass of 63.55 AMUs. 1 mole of copper has a mass of 63.55 grams. So all those numbers on the bottom of the periodic table, the ones that we've been kind of ignoring lately, ladies and gentlemen, now we're going to start using them. Now we're going to start using them. Okay? Now we're going to start using them. Questions? Anyone need more time before I switch the slide? Wonderful. Awesome. So let's start calculating formula masses, lady. Oh my goodness. Wow. That is an incredibly terrible color to use with that slide. What color do you like? Blue and purple. All right, we'll go with orange. No. Dark red. There we go. All right, that's better. All right. Boom. Boom. So if your formula is AlCl3, why would your formula be AlCl3, ladies and gentlemen? Well, why is the formula AlCl3?
It's aluminum blood.
Okay, so what? So why isn't it AlCl? Why isn't it AlCl2?
You have to have the subscript.
The charge.
Okay, so let me pick one. AlCl1.
No, there's no ones.
Okay, AlCl.
The charge.
What about it?
You have to make it 0.
We still need a compound that has a total charge of 0. So to get a total charge of 0, for every 1 aluminum, there have to be 3 chlorines, right? So this compound then contains 1 aluminum and 3 chlorines, correct? Okay, good. So what is the mass of each of the parts? What is the mass of aluminum? 26.98. Now what's it on your periodic table?
26.9.
Okay, good. That's perfect. And for chlorine, 35.45, correct?
Yes.
Okay, good. But how many chlorines do we have here?
3.
3. We need to account for that. So not only do we need the mass, but we need to account for how many are in your formula. Okay? So the formula mass, it is the mass of each component times the number of each component. Yes?
Is PT the unit?
PT, periodic table. That's where I got these numbers
Okay,
from. Sorry.
okay.
My bad. Thank you for asking. That's where I got these numbers from. Where do I get the 3 and the 1 from here? The formula. These numbers come off of the periodic table. So, and we're going to do this for each element in the compound. How many different elements are in this formula? 2. Okay? So we're going to take the formula mass of aluminum, 26.98, times how many aluminums there are? 1. We're going to add it to 35.45, the mass of chlorine, times how many chlorines there are? 3. This, ladies and gentlemen, is now our formula mass. 133.33 grams for every 1 mole of aluminum chloride. That's how we find formula mass, ladies and gentlemen. We need our formula, we need to know how many, and we need to know their masses. Now, how many times do you need to do this?
Depending on how many you have. How many elements you have.
Thank you. These factors are dependent on how many elements are in your compound. You have 2 elements in your compound, you need to do 2 of these. You have 5 elements in your compound, you're going to have 5 of these, ladies and gentlemen. Now, here's what I will tell you as well, ladies and gentlemen. When you are working with your calculator and you are calculating formula mass, I try to do it all at once. Okay? I try to do it all at once. So yes, I put these things in parentheses. Now, do I need to do the times 1 here? No. But when you're adding this, these need to go in parentheses, ladies and gentlemen. Then you do your next factor and your next factor and your next factor. Okay? Because you've got to get the right answer for this. Okay? All right, here we go, ladies and gentlemen. Oh, look at there. Another beautiful choice of colors. Nice job. Nice job. You are awesome at this. All right, you wanted blue before. We'll go with blue now. All right, there we go. We're going with blue now. Okay, so here is our next one, ladies and gentlemen. Formula C12H22O11. Anybody know what this is, ladies and gentlemen?
Yes.
Yes, what is it? Don't look on the back of your periodic table. That is not even close to acetate. Acetate is C2H3O2. You're right, it does have the same letters as acetate. This, ladies and gentlemen, this is sucrose. This is your sugar at home. This is what you add to coffee. This is what you put into things when you bake. Okay? This is sugar. Now, what is the mass of every carbon atom? 12.01. What is the mass of every hydrogen? 1.01. What is the mass of every oxygen? 16.00. Where did I get those? Off of the periodic table, ladies and gentlemen. And again, if you choose numbers that are slightly different than this, so be it. We will be fine. Okay? So now, we're going to do formula mass, which means we're going to take the mass of each component times the number of each component. We do this for each element in the compound. For every one. How many elements in this compound? 3. You're going to do it 3 times then, ladies and gentlemen. 12 times 12.01. Anybody? Top of your head? Really? We can't multiply 12 and 12. 144.12.
Yeah.
Okay? 22 times 1.01. 22.22. 11 times 16. 176. Come on, people! Come on! It's math. 342.34 grams. When I have 342.34 grams of sugar, I have 1 mole of it. I have 1 mole of it. What would happen if I had 684.68 grams? You'd have 2 moles of it. Very good. What happened if I had 3,423.4 grams? You'd have 10 moles of it. Hey, now you're getting it. Now we're seeing this. Okay? So if I have 10 times the number of moles, what's going to happen to the mass? It's going to be 10 times larger. Good, 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 good. Wonderful, ladies and gentlemen. The good news is, next class, they're not going to have this problem with the white slides that they can't see. All right, you wanted purple? I'll give you purple this time. There you go. There's purple. All right, excellent. Sorry, ladies and gentlemen. I changed the background on it to make it better for you, and apparently I didn't do a very good job there. So, okay, what if your formula is magnesium nitrate? Well, 1 magnesium. How many nitrogens? 2. How many oxygens? 6. On the periodic table, magnesium is 24.31. Nitrogen is 14.01. Oxygen is 16. So 1 times 24.31 plus 2 times 14.01 or 28.02 plus 6 times 16, 96, gives us 148.32 grams per 1 mole of magnesium nitrate. Now, what would happen, let's just say, ladies and gentlemen, if you forgot the 2 outside here? Yeah, we're not getting the right formula mass, are we? If you can't write the right formula, there's no way you're getting the right formula mass, ladies and gentlemen. Anyone need more time?
Yeah.
Okay. So what I will tell you, ladies and gentlemen, this becomes incredibly important in Unit 7. Okay? So right now we're building the pieces for Unit 7. In Unit 7, you're going to be able to take a given amount of one substance plus a given amount of another and predict how much product you will be able to create. But you can't do it if you can't take the amount that you're given and convert it into moles. Okay? Can't do it if you can't take the amount you're given and convert it into moles. Now, all we're doing is finding the formula mass right now. In a few minutes, we are going to take and use this to figure out how many moles there are of something. Okay? But we got to begin with the basics, which is how do we figure out what the formula mass is? Well, we use the formula. Okay? And we use the mass of each part of the formula. Questions? Now, here's the nice part. The mass of carbon never what? The average mass of carbon atoms never what? Never changes. That's why they can put it on that periodic table. Now, eventually, if we use things often enough, you'll learn that oxygen is going to be 16.0. You'll learn that nitrogen is 14.01. For now, you're going to probably have to spend some time looking them up. Okay? You'll also figure out where they are on the periodic table a lot easier. Can I move this slide on? Good. Excellent. Let's not do that yet. What's that? What's that all about? Come on. Everybody loves a good worksheet, right? Right? See, Angel said he likes worksheets. That's why I'm handing them out. He had said no, I would have put them away. What? You take one and put 2 there. Phoebe, how long have we been together in class? 12 weeks, right? If you haven't figured out that I'm lazy and I'm not handing one out to each person yet, that's on you, okay? That's on you, Phoebe.
Mr. Brown, you said we can use our ID or phone to change your calculator.
I never said you could use, to exchange for gun? No, you can go grab one right now if you need a calculator. You don't need to bring me your ID or your phone yet. We may get to that, but not yet. Let's go. Grab a calculator, ladies and gentlemen. How come that one says brain on the back?
No, it doesn't. He's on the stroller.
Uh-huh, I see that. All right. So there is a practice one that is done for you, ladies and gentlemen. We are going to look at number 2 real quick here. Now, the first thing to doing these problems, ladies and gentlemen, is I need a correct formula for sodium sulfate. So who can give me a correct formula for sodium sulfate?
Na2SO4.
Na2SO4. Are you sure?
No.
Yeah. I'm sure.
Yes? Okay, that is correct. Sodium plus 1, sulfate minus 2, Na2SO4. So what elements are involved in this? Give me the elements, Ariana, that are involved in this. You can either give me the names or you can give me the symbols.
Sodium, sulfur.
Sodium, what?
Sulfur.
And?
Oxygen.
Very good. How many sodiums in this one? 2. How many sulfur? How many oxygens? Okay. So, there I've told how many. So, there are going to be 2 sodiums. What is the mass of each sodium? 22.99. There is 1 sulfur. What is the mass of it? 32.06. There are 4 oxygens. What are the mass of them? 16.0. So, with your calculator, 2 times 22.99 plus 1 times 32.06 plus 4 times 16.0. 142 point what? 04 grams. Thank you. Okay? So this is our formula mass. Now, technically, I agree with the grams part. Technically, though, it is grams per mole. Okay? It is grams per 1 mole of sodium sulfate. Okay? Questions? Okay. Go to work, ladies and gentlemen. If you have questions, raise your hand, call me over. I will be happy to help you. If you wish to work